Alright. The next thing I want to talk about is exothermic versus endothermic. Alright, so let's talk about this very quickly. So, you guys just did, basically, you modeled an exothermic and an endothermic reaction.
Yep.
The sodium hydroxide is an example of an exothermic reaction. And what you guys notice, as soon as you put the hydrogen or the sodium hydroxide in the water, what happened to the temperature of the water? Why?
Because of
The chemical reaction.
And what's going on with the chemical reaction? What is the chemical reaction doing?
bond.
It's releasing energy.
Yeah.
Okay? And it's releasing that energy in the form of heat. That's what exothermic reactions do. It's a chemical reaction that releases heat energy. Okay, and that's basically coming from the breaking of the bonds between the sodium and hydroxide ions. Alright, so when we think about exothermic, it is releasing heat energy. Now, endo, think about endo. What does endo imply?
Inside.
Inside, so endothermic is requiring energy to be put into the system in order for the reaction to take place. Your citric acid with sodium bicarbonate, which is baking soda, sodium bicarbonate, requires energy from outside that system in order to react. So what it's literally doing is drawing energy from the atmosphere and drawing that heat into the reaction, therefore the reaction feels colder. So basically, endothermic absorbs energy. Absorbing that heat energy. Now, one of the central themes for earth science. One of the central themes of earth science is one thing that you guys need to write down and remember for the final exam. Central themes of earth science. Energy flows from highs to lows. Energy flows from highs to lows. So right now, I want everybody to do this for me. I want you to take your right hand and put it on top of your desk. Take your left hand and put it on the front of the desk.
Where's the front?
This stuff.
What?
No, it doesn't matter. Just put
Other hand.
right hand on the desk, left hand on the front of the desk. Okay. Now it can't be on the top. It's got to be on that gray front. Like right in front of you guys.
I can't. This is so easy.
Like this. You're sitting like this.
Yeah.
That's how you're sitting.
Oh my God.
Yeah. Okay, now.
You said that part.
Okay, now. Which one's colder?
The bottom. I don't know my hands.
The bottom.
I think we're pretty kind of
My left hand is colder.
top
Right,
of
right.
one is
Okay, stop. Stop and let's think this over. I want you to take a cup of coffee, fresh out of the pot. Okay, now, hold on. And then I also want you to take ice water. We got water from the fridge, and we're going to put some ice cubes in it. Which one's hotter?
The coffee.
Okay, good. Let it sit. Let both of them sit for 3 days. Which one's hotter?
the water.
They're both the same. Why?
Because they both have room temperature.
Because given enough time, we're going to go from highs, we're going to work our way up to room temperature, right? Guys, these tables have been here since the school opened. What temperature do you think the table is? The room temperature. The front of that table hasn't left the room either. So what's the temperature of the front of the table? Room temperature. But yeah, which one feels colder? The top. Top, because it's a better conductor of heat. And here's the other thing. When things feel hot or they feel cold, what it is literally a transfer of energy. What it is, the reason why this top feels cold is because your body is hotter than the top of that desk, and literally the heat energy from your hand is flowing away from your hand and being absorbed into the tabletop. Highs to lows. Since you're hotter than the tabletop, the energy is moving from your hand to the tabletop. when things feel cold, that's literally what's happening. It's taking heat away from you, and therefore it feels cold.
Is that why, like, if someone comes and places their hand after it later, it's warm?
Yeah. It's absorbing that energy to hold on to it. Now, on the flip side of that, if something feels like really hot, what your hand is doing is taking the heat energy off that item and absorbing that heat energy. Alright, so we are always moving from highs to lows with energy. So that's kind of an important thing to remember here. So when we think about endothermic and exothermic, with the sodium hydroxide, the bottom of that Erlenmeyer flask got really warm, didn't it? That's because it's releasing that energy from the solution to your hand. And then the citric acid, after adding the baking soda,
It got really cold.
it got really cold. It felt like it got cold.
Yeah.
Because it was stealing the heat energy out of your hand. And in fact, you actually were watching the temperature drop. And in some years, if you actually watch it closely, if we had enough time for that, that can drop upwards of 10 degrees Celsius, which doesn't really seem like a lot. When we start doing the math, it actually adds up fairly quickly over Fahrenheit. Okay, it's a pretty sudden drop. All right, the last thing I want to talk about today is synthesis and decomposition. What does it mean to decompose? To break down, to decay. So when we think about decomposition, it's exactly that. It's a reaction that is breaking stuff down. So a decomposition reaction breaks down substances. An example of that is when we took the sodium hydroxide, which was NaOH, and we break it into sodium and hydroxide. That's decomposition. You're literally breaking it apart. Okay? We did the same thing. Remember when we lit the hydrogen gas on fire with the water, sending an electrical current through the water, and we actually split it into hydrogen and oxygen? That's another example of a decomposition reaction. Synthesis, on the other hand, is when we're putting things together. So if you want to think about that, you can think of it like taking salt. If we have salt water, you have sodium ions and free-floating chlorine ions. And when the water evaporates, these two guys go find each other, and we end up with sodium chloride. All right, so that's an example of synthesis reaction where we're putting things together. So synthesis puts things together, decomposition breaks them apart. And that's all I have for us today.